Da-da-da, da-da-da-da-da-da-da. Let's finish up how we do these chi-squareds. We've talked about the equation for it. Let's actually do it for this data set. So here's my equation. Here's how I do it. Let's try starting it. I'm going to make me a third table. I'm going to give it the column for vanilla, chocolate, cookie dough, and whatever the last one was. We've got male and female. For the first one, here, the male vanilla, my chi-squared is 0.001. I got that by taking how many males like vanilla, subtract how many males were supposed to like vanilla, and then divide by how many males were supposed to like vanilla. 10 minus 10.1 squared over the 10.1. There's my 0.001. What do I get for the males who like chocolate? It's 0.007, a little bit higher because 22.4 is a little bit further away from 22. It's divided by the 22.4, which is why I didn't make it even higher, but 0.007 is what I get. Now, an interesting one is going to be the males who like cookie dough. Interesting because it's a lot bigger, 0.698. The 54 minus the 48.2, there's a bigger difference there. 0.698 being bigger tells me what I expected and what I observed were not as close. Here, 0.001, it was really close, 10 to 10.1. But something here was further off, 54 to 48. So now I'm starting to see there are some differences. Will it be enough? Well, let's finish it out. Males who like whatever that last column was is way huge. Look at that, 2.28. From 7 to 12 is a big difference when you're only talking about 12 to start with. So out of all the different things about men, what is weirdest? What's weirdest is this last column. Why? Because there's supposed to be 12 guys who like sherbet, and we only had 7. So that tells us that the guys have a category that was unexpected. According to the null hypothesis, this shouldn't be happening. Is that a lot or not? Well, let's go ahead and finish out. The women who like vanilla, chocolate, cookie dough, and sherbet. Well, now we can answer the question, who is most weird? And the answer is the biggest chi-squared here. The women who like sherbet are weird. Okay? Maybe 9 of you should like sherbet. It turns out to be 15. Why is it that my wife loves sherbet so much? I don't know. I don't understand. But there is our table of, these are called partial chi-squareds, because to get the chi-squared, you want to add them all up. Which, using math notation, you would use that capital sigma to mean add them all up. You've seen that once before with the summation notation in the standard deviation. Okay, so for us, our chi-squared value with 3 degrees of freedom is what you get if you add all these up, 6.79. Is that a lot? Well, I don't know. It's kind of like talking about z squared, so if I square rooted that, maybe I could get an idea. But we are going to use the applet to tell us how big is that really. So here's the applet we're used to using. It's time for us to go to the chi-squared distribution. Now, one thing to notice is that it is not symmetric. It is skewed. And the reason for that was because we squared things. And when we squared things, the negative half flipped over to the positive half. So for chi-squared testing, we don't ever have to worry about left-tailed, right-tailed, tooth-tailed. It's always right-tailed. So I always want to flip the sign on that. Now, what's my degrees of freedom? I'm going to do that first, or else it'll mess up all my other numbers. Degrees of freedom was 3. So there's what the curve looks like with 3 degrees of freedom. My chi-squared value was 6.79. And there I get a probability attached to it. That is the p-value. So now we are ready to do a full-on hypothesis test.